good at graphing, most of this becomes a useless activity in what we're going to do. But you need to see all of these. So we're going to look at how to solve by using a plus-minus table, and we're going to solve by analyzing the graph. And you won't need a graphing calculator to do this. We're going to use one of these or the other when it's appropriate. In order to kind of start it off, we're going to start off with something that you don't need to solve with a graph or a plus-minus table. If you have 3x is greater than 2, you're not going to set this and make this 3x minus 2 is greater than 0, and then call the left side p of x, so p of x is 3x minus 2, and graph it, and look at the graph and say, oh look, this is where the graph is greater than 0. If you're going to solve this, what are you going to do? Divide by 3, done. X is greater than 2/3. That's all you need to do. That's not why I'm showing you this. I'm showing you this so you understand how it applies when we get to things that aren't so simple. So when we set this equal to 0 on one side, whether it's inequality or equality, we can then look at this side and we can say, okay, let's look at this graph. Where are the values for p of x, the y values? Where are they bigger than 0? Well, that's when they're above the x-axis, and it's on this side of the graph. The x's where that occurs are the x's that are greater than 2/3. So our interval would be from 2/3 to infinity, our solution. Again, not how you would solve this problem. You would just simply divide by 3, and there's your interval. Easy to do. 3x minus 2 is greater than 0. Another way to do this would be to find the roots and then plus-minus test it. So if we treat this and we say, okay, we're going to solve when we find the root is going to be where x is equal to 2/3. So here's 0, here's 2/3. Because this is a greater than, not a greater than or equal to, do we include the root? No. So I would circle the root. Pick any number to the left of your root. There's only one root here, so you have left side and right side. Pick a number to the left. I'm going to use 0 and plug it in. Okay? To 3x minus 2. If you put in a 0, you get a negative. The left side to the left of your root is negative values. To the right of 2/3, put in 100. 3 times 100 is 300 minus 2. That's a positive. Don't care what the numbers are. Just care if it's positive or negative. When you look at your inequality, we want the function to be greater than 0. Which of these is greater? That's the positive. So my interval is from 2/3, again, to infinity. No mystery here. All right. 2/3 to infinity. Again, this is a really simple example, and I just want you to see the process was super simple because that'll make it much more, much easier for you to understand when we go to the polynomial where the degree is 3s, 4s, 5s, etc. And the rational is more important. So this is a polynomial function. It's a quadratic, and it's an equation. And you already know how to solve the equation. You have multiple ways to do it. What are the ways that we can solve this equation? Factoring, your favorite F word. What else could we do? Quadratic formula. Complete the square. Okay? I'm going to show you 2 other ways to solve this. Right? Now the factoring, the completing the square, all that is for solving the equation, and that's great. Well, I'm going to show you 2 ways to solve the inequality. When we factor this, bless you, it would look not like that. It would look like that, right? So that's going to give you solutions of x equals -5/2 and 1. You've been doing this for a long time, mathematically speaking. You guys are pretty good at this. questions on solving that? That's not what today's about, but you guys are all good at that. What did we find if we think about this as a function? If we think of this as f of x equals 2x squared plus 3x minus 5, what did we just determine? The roots of the zeros. Okay? So I'm going to show you how to solve these graphically. And in this particular case, and in fact, all polynomials, for me, this is how I do it. And I'll show you that this one's too easy, but we'll do more complicated in a minute. We know the roots, because when you factor this, you can find the roots. And you found the roots are going to be at negative 5 over 2 and 1. So at negative 5 over 2, and 1. These roots are not included, so I'll open circles on them. The degree of this polynomial is 2. The leading coefficient is, the end behavior is up and up. At least one of you knows that. So 35 more and we'll be all in business. So all I need to do to graph this is do what we've been doing all along. This is a parabola. I could even find the vertex if I wanted. Don't care. But I know the vertex is down here somewhere. I could go halfway between these two and plug it in, or I could do opposite of b over 2a. But don't care. I really don't. It's going to be up and through and through. That's the general picture. That's all I need to know about this. The question is saying, what value of x is going to give me results that are less than 0? The ones that are less than 0 are down here. It's between your two roots. So my interval that's going to be the solution here is going to be from negative 5 over 2 to positive 1, shun, shun. No, that's the x-axis. Those are x values. We only care about the x's. Look at your yellow. Between these two x's are the x's that give you values that are negative, right? When you point at something, that's what I know. I didn't include the right circle. Pick an x. Pick an x. Okay, then you're going to have to plug it in your calculator. Plug in 0.99 on your calculator. Now, there's no way you're making me do it. Just use parentheses. It's easy. 3.99 squared plus 3, so that's 2. 0.99 minus 5. What did you get? It doesn't really matter other than the fact that it's negative. Negative is a solution, right? So 0.99 is included in this. 1 is not. If you pick x as 1, don't you get 0? When you pick x as 1, don't you get 0? Absolutely. It's a root. And in between these two roots, every y value you get, if you treat the left side as the function, won't you get a y value that's negative? Yes or no? Yes. So that's what we want when the y values of that function are negative. What x's generate those? The x's from here to here. If you pick negative 5 over 2 or 1, your y value will be 0. That's no good. And when you pick numbers to the left, you're going to get positive values here, and to the right of 1, positive values here. That's not what we want. Everybody good? That's solving it graphically. Same function, we're going to solve plus minus testing. So again, we factor and set and find the roots. We're setting it equal to 0, plus 5 minus 1. So your roots are still negative 5 over 2 and 1. Here's negative 5 over 2. Here's 1. Here's 0. We're not including the roots, so we circle those. Pick a number to the left of negative 5 over 2. Pick a number to the left of negative 5 over 2. Don't pick negative point something 99999. Pick something you can do in your head, like negative 10. When you plug in a negative 10 and you square it, you're going to get 200. Minus 30 minus 5 is going to be a positive value. Don't care what the number is, I just know it's positive. What should I pick between these two? 0, that's easy. These guys are gone, and it's negative. And then to the right of this group, pick 10. Positive, positive, big, minus 5, it's going to be positive. Don't care what the numbers are, just positive or negative. If you can't do that in your head quickly, it would take you probably 10 seconds tops to plug in any number on your calculator to get a positive or negative. Keep it simple. Keep it simple. Don't pick 0.99. That's not what you want to plug in.
What did you plug into?
Anything between negative 5 over 2 and 1. What did you plug in? The 1? You mean this negative sign? Just pick any number between negative, because you're testing an interval. So we have this interval, we have this interval, and this interval. You're picking any number you want that's in the interval. Pick negative 1,000,000 if you want. Pick anything between these two. 0.999. For me, I pick 0. What do you want to pick? 0. It's easy. These things disappear. Are you getting a positive or a negative? Negative. That's why I put a negative there. And then to the right of 1, I pick 10. You can pick 1,000,000. You can pick 1.001. But seriously, do something that's easy. Do something that's easy. So our interval that we want is where it's negative, again, between, that's really not what I want, negative 5 over 2 and 1, shun. Same as before. Honestly, it won't make any difference at all what number you pick as long as you pick it in each interval. And pick whatever number is easy for you to work with. I like 10s, I like 0s, 1s. You know, that's a good one too if you can get it. I don't like fractions, but sometimes it's unavoidable. Everybody with me on this? Plus minus test it. Graph it. It's going to give you the same results. If it's polynomial like these, and regardless of the degree, I will always graph them. Because graphing is easy and it's fast. Once you know your list, degree, leading coefficient, and behavior, and you know your roots, okay, when you know your roots, we have them at negative 5 over 2, 0, and 1, 0. And they're single in a single, the graph's easy.
For the plus minus testing, how do you figure out which way the graph is going from the graph?
Right here. Less thans and greater thans are shuns. Less than or equal to's, greater than or equal to's are hugs.
Then why are we doing the line?
Why are we doing the line?
Can't you figure that out just by verifying the ones and the
What negative 5?
negative 5 acts like
Got a lot of incomplete thoughts on that one.
yeah, I got it.
Because I have no idea what you got. Are you good?
I was just like, what are we looking? What's the
This is how I'm showing you multiple ways to do it. On this page right here, we're doing a plus minus test to figure it out. The way I did it is I found the roots. I circled them open because it's a less than. That means these can't be part of my answer. I picked a number to the left, plugged it in, and got a positive value. Picked a number in between, plugged it in, and got a negative value. Picked the number to the right of the 1, got a positive value. I want the ones where the graph will be negative. The interval that's negative is between here and here. That means any x that's between negative 5/2 and 1, non-inclusive, when I plug it into this inequality statement, will be a true statement and therefore a solution. This is how we write the interval of the solution. Does that make sense? You sure? This is by plus minus testing. I did the same exact problem graphically by graphing what the graph of the left side of the inequality would look like. It would be a parabola, horseshoe up, vertex below the x-axis with these two x-intercepts. The x-intercepts cannot be included, so I circle them, open. Where is it below the x-axis? It's this interval between here and here. Same results. Does that make sense?
How much would it change for the greater than?
You would have a closed circle here, a closed circle here, and these would be a hug and a hug.
Oh, so that's it.
That's it. It's still the same interval. This is still where it's below the 0, but this would be where it's equal to 0.
All right.
So less than or equal to 0, we've got to include the roots. That's a good question.
For these type of problems, do we have to tell you, it's like a simple, do we have to do it, or do we just do the roots and then put it in? We'll solve it from without doing the line plus minus. With any testing, can you just put it in straight into the calculation?
And you don't have a picture or a plus minus table?
Well, yeah,
Well, I want you to explain to me what you're going to do. You're going to have this inequality. You're going to factor it. You're going to get these two roots. How do you know that they're in between the roots? Here, let me just give you an example. Now the graph is horseshoe down, and the solutions are outside the roots. No. I mean, it's not that it just happened. It's the values of x that give you negative y's are here between the intervals. I'm not sure.
no, I know, I'm just,
But if this is a negative 2, my graph is going to look like this, right? And your interval would be from negative infinity to the root, union from the root to positive infinity. And I'm wondering how, without either graphing or plus minus testing, how are you going to know?
well, I know, it's just, this worked out where that was the answer.
It was the answer, in between the roots. Is that what you meant?
Yeah,
I agree with it that that's true, but again, we started with a linear that there's no way we would ever do any of this. We've gone to a quadratic, which I think you could see value in graphing and see that the graph below is where the interval is. Or I think you could probably agree that there's even merit to doing a plus minus into your function. But again, what we're going to be looking at in the next one is that you're going to have a third degree polynomial or a fourth degree polynomial. And again, my question is, so you have these intervals, these roots, how do you know which intervals are you going to take is my question for you. And if you have a way that doesn't require doing this, I think you should share. Okay, so it's a visual, and I want to see the visual, either the plus minus test or the graph. And if you have another way, you just need to tell me what that other way is. Divine intervention. I was encompassed by a bright light, and I knew the answer. If that's the way it's working, then I'm going to need to see that. But that's not it. It'll make a little bit more sense in a second when we do the next one. Right? No? Somebody? Okay? Remember, we're building up to more complicated. All right? So, So now we're looking at a cubic, okay? And this cubic function, factor completely, is what we're going to do on this one. You're not always going to be so lucky, as you will see. And find zeros. So how do we factor the x cubed minus 2x squared minus 3x? Take out an x. So if we take out an x, you have x squared minus 2x minus 3. And that's going to factor to x times x minus 3 times x plus 1. So you're going to have x equals 0, 3, and negative 1 if I calculated correctly. So you use a graph to test the intervals. Now, for me, I'm not plus minusing this. There is no stinking way you're going to make me plug in to each of these intervals. So what it looks like is you have, here's 0, here's 3, here's negative 1. Okay? We're going to be open circle on each of the roots because it's a less than. What is the degree of your polynomial? 3. The leading coefficient is positive, so the end behavior is down and up, and each of your roots are singles, right? Single, single, single. That means you're through all of these roots. So if we're down on the left, we're going to come up, down on the left, go through, go through, go through, go through. That's what the graph would look like. We want to know when the graph is less than 0. Where is that? Easy to see. Okay, it's right here, that's less than 0, and right here, that's less than 0. Everything else is above the 0, or equal to the 0. So we're going to identify the two intervals, which is going to be the union. Here's where we want to be, here's where we want to be. So we're going to go from negative infinity all the way up to, but not including, negative 1. And then we're going to go from 0 to 3. That's how I would find the solution to this problem. I would use the actual graph of the polynomial function. Now, granted, the graphs, relative maxes and mins, they're not where they're supposed to be, but I don't care. I only care about plus or minus. Everybody seeing this? If you have a graph, yes, absolutely. I don't want to see things that you should have listed done in your head. I want to see the work. Now, if you are a plus-minus believer, you believe in the plus-minus value of testing, then you can do that as well. You can plug in a negative 10, that's going to be a big negative. And then minus, so that's more negative. And then plus something, it's still going to be a negative out here. And then you can put in something between 0 and negative 1, maybe negative a half. Plug that in if you want. And then you can plug something in between 0 and 3, and then to the right of 3. So you're going to have to test here, 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 and here. 4 intervals to plug in. I think it's faster to do it this way. It's up to you, though. Right? Kelly, does that make sense? More sense on this one than it did on the last one, right? Okay. Any questions here? Yep.
So do you just plug your numbers to see if it's supposed to be positive or negative?
Yeah. If you like doing plus-minus testing, yes. You're picking a value of x in each interval. So here's your 0. We have to go to the left of that. Pick anything smaller than negative 1. Negative 10 is good. Negative a million. Between negative 1 and 0 is another interval. You got to pick something in between. Negative a half would work. Again, on your calculator, it's easy to plug in negative 0.5. Just make sure you use parentheses in all the plugins.
Well, with the graph, how did you know it was
the left is down.
Yeah,
Right is up.
I see what it's supposed to be, but,
Okay.
like, I understand, like, the shape of the graph,
Yeah.
but it's just, like, how do you know that the, end result would be, like, the
We want to know when the graph is less than 0. That means the
Okay.
y values are less than
so
0.
if it was greater than it.
Then I would take
Okay.
this, and I would take that. Okay? It's not a Ouija
Yeah.
board deal, like, oh, this interval, right?
Well, that's one of the just go on.
I did that.
Yeah, I know.
Like clairvoyant, huh? Yeah, Ouija board is not the way to go on. Anybody good at the Ouija board? Well, if you can, the Ouija board, that's real if you have psychic powers. Everybody can't do the Ouija board. Only people who have the power to contact out of this realm. It's like the magic 8-ball. You could use the magic 8-ball test. Should I take the interval between negative infinity and negative 1? And we ask the magic 8-ball, and this magic 8-ball says, reply hazy, try again. So clearly I have issues. Let's see what this magic 8-ball one says. Don't count on it. So see, I have no power. Sorry, this magic 8-ball is broken, by the way. But I do have a crystal ball that allows me to see the future too. So I know that this is the right answer. I don't need those. I like that. All right. So x cubed minus 2x squared, same deal. Oh, this one, I guess I was supposed to plus minus test for you here. I just can't bring myself to do that. What's that?
I was wondering why there wasn't a Y.
Yeah, because I just got out of order here. So if we were gonna do this, so it was, we were gonna get -1. What were the other ones? 0 and 3. Okay, and we've already done this. So the graph, if we had a leading coefficient that was positive, the end behavior, the degree. Open. Right. So really, we want the negatives, so we're going to be down here. So on this one, what I guess they really wanted me to do, plus minus, that's that. 0. You can see how much I don't like doing this. Okay, so we're open, open, open. And this is where you would pick your numbers. Like -1.0001. But the rest of us might want to pick -10. You can do it in your head. You get -1,000. -1,200 plus 30 is going to be a negative out here. The half, the -1/2 is a little bit trickier. That's going to be a -1/8. That's going to be -1/2. And then plus 3/2 is going to cancel that out, so that's going to become positive. Between 0 and 3, you can put in a 1. 1 minus 2 minus 3, that's negative. And when you put in a bazillion cubed, minus 2 bazillion squared, minus 3 bazillion is going to give you a positive. Okay. So where do you want your intervals? You want them where they're negatives, which is here. With polynomials, I never do that. I hate doing plus minus testing. It's not difficult, it's just a pain. Now with the next ones though, you need your scientific calculator and you need to be able to do that. Graphing calculators are great, but they're not going to help you on a test, and you need to practice with the scientific. Okay? Any questions on these two polynomials? Same one, just different ways. So here's one more polynomial we can do real quick. And this gets you the greater than or equal to, so that's going to make a little bit of difference. We're going to do it by graphing because I'm not doing plus minusing anymore in the polynomials. So what's the degree? Degree is 4. The leading coefficient is positive, so the end behavior has to be up and up. Different on that? Is that you, Lexi?
What?
Huh?
What?
I don't know. Everybody good on those three? Okay, so what are the roots? This is x plus 1, x minus 1, x minus 4 squared. What are the roots? 1, 0, negative 1, 0, and 4, 0. What kind of roots? I don't know. Single, single, double. So here's negative 1, here's 1, and 4. This time we're including the roots. So I fill in the circles in the graph, just so I know I'm going to include my roots. 4 is my double. My end behavior is all I need to do the graph. So we're going to come up, we're going through. We're going to go through. We're going to come back, go through. We're going to bounce. And there's our graph, sketch. We want to know where it's positive. So the interval where it's positive is going to be here. Bless you. And here. How do we do the interval on the left, Mitch?
Wait, brackets, negative 1, or sorry, negative infinity, comma, negative 1.
Negative 1.
Close.
Okay. Yep. And then we're going to go union. Derek, how do we do the second interval? The hugging one. Never thought this class was going to be touchy-feely, did you? Then what? Yes. I could live with that, I guess. But really, instead of this, we should have done union 1 comma infinity. Does that work for you? No reason to break this up just because we had a root. The root doesn't change the fact that it's everybody to the right of 1. Yes, Buzz Lightyear. Okay? Yes.
It's not root with.
Then you don't have a choice. You got to do the way that Derek did. But and these would be shun. But that's not the way it is on this one. Okay? I think there is a tricky one coming up here in a minute. Okay. Everybody good on this one? That's done? Now this one's polynomial, this one's rational, not polynomial. So we haven't done these in a while. So just to remind you, when it's a rational function, you want to find your roots by setting the top equal to 0. You find the roots first by setting the top equal to 0. Alright, so in this problem, my roots are going to be where? Negative 2, 0, and 5, 0. And 5, 0 is a double. That's not going to matter to us too much right now because we can't use graphing. Well, we can, but I'm not going to. We can't really use graphing successfully without a whole lot of work to make out what these pictures are going to look like. The asymptotes. To find a vertical asymptote, you set the bottom equal to 0. If you set the bottom equal to 0, the vertical asymptote occurs at x equals 4. So on this plus minus table, what I do is I say, okay, my roots are going to be at -2. Here's 0. And then we're going to be looking at a 4 we'll need and a 5. My roots are going to be at -2, and I'm filling this in because it's a root that I can keep, and 5, right? Filled in roots because they're part of the solution. The vertical asymptote is never part of the solution. And I like to keep or differentiate between asymptotes and roots. And if it was an inequality less than or greater than, they would all be open circles and it would be confusing for me. So regardless, when it's an asymptote, I put a dotted line through the open circle. And then I plus minus test it. So this is -2, even though it doesn't look like this is a -2. Pick a number and plug in. Now the plugging in, again, some of you are going after your calculators and that's great. But remember, all we need to know is plus or minus, and this is already in factored form. It's pretty easy. If you plug in a -10, this binomial becomes negative. Don't even care that it's -8, just that it's -10 plus 2 is negative. This binomial squared is always a positive, so we have negative times positive over -10 minus 4 is a negative. Negative, positive, negative means positive. 2 negatives, 1 positive means a positive. In between -2 and the asymptote of 4, we check this interval. I'm going to put in a 0. So we're going to have positive, positive, negative. So what's that interval? Negative. Between 4 and 5, 4.99999. In me, I'm going to pick 4.5. 4.5 plus 2 is positive. Positive, 4.5 minus 4, positive. That interval is a positive. And then the last one, you put 10, positive, 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 positive. We want to know where the function on the left is below the x-axis 0. The only place that that occurs is the interval here, right? So what's the solution going to be? How would you describe the solution? -2, comma 4. Hug and shun. Everybody good with that? Is that the solution? That's correct, and it's not. That's why I'm shunning the 4. Shun on 4 means 4 is not included, right? And it can never be included. Under no circumstances can the asymptote. You always have to shun around the asymptote. So this is good? What about it? Excellent observation. Since this is or equal to and it's filled in, we can't just ignore it because we're plus around it. This value of 5 actually makes a true statement. So what do I put? Union of the 5. Great job. So don't overlook that because of the plus. The 5, when you plug it into the original, will make the equation true because you're going to get 0 is less than or equal equal to 5, that's true. But around the 5, not true. Everybody good on that? Well, because the asymptote is out of bounds. It's not an included value, and it makes a new set of intervals. Your graph is going to be divided by your roots and your asymptote. Okay, so the asymptote acts like a root in that it creates intervals, but there's no way the asymptote can be included as a solution. So if you eliminate this asymptote, you'd only have the interval from 0 to 5, and you can see in between here we have a change, plus minus change. If we don't identify that asymptote, that's going to be a problem. Okay? Now we know when we're graphing, we typically do not cross asymptotes with our graphs. Vertical asymptotes, there's no way you can cross it. Okay? You can't touch a vertical asymptote. Horizontal asymptotes, we sometimes cross those. Vertical asymptotes, no way. Best case scenario is you have a hole in your graph. We haven't dealt with any of that yet. Okay, but the asymptote, you can't, it's like out of bounds. Okay? Did I answer your question? Everybody good here? Okay, try this one. Very good. All right, so the roots, we set the top equal to 0. How does it factor? And x plus 7. So your roots are 9, 0, and negative 7, 0. Asymptote, where is that? X equals 4. So when we set this up, so here's 4, here's 9, here's negative 7. We are open or closed on your roots? Open on negative 7, 9, and your asymptote is always open. And just so I know the difference between my roots and asymptotes, I put a dotted line. If you plus minus test, to the left of negative 7, you can put in a negative 10. You're going to get a positive, plus, and then minus 63. It's still going to be positive, but negative 10 minus 4 is negative, so you should be negative out here. Putting in a 0 in between these two is going to give you a positive. In between the asymptotes, in between the asymptote and the 9, you can put in a 5 or a 6 or a 7. When you plug that in, you're going to get a positive on the bottom. 49 minus 14 minus 63, that looks like a negative, is that right? And then to the right of 9, you can put in a 10, and I think that's going to be positive also. So your interval is to the left of negative 7, which means negative infinity, up to but not including negative 7, and then between the 4 and the 9. So from 4 to 9, not including either of those, which is what I saw in everyone I looked at.
Where we did the graph?
You graphed this. How did you do it? We haven't graphed any rational functions yet. You can't use degree and leading coefficients. Did it like what? So let me just tell you, you were fortunate. Okay? First of all, does your graph, what does it look like at the asymptote?
It looks like that, but I just did a lot of
Okay.
it works, but
Okay, I'm just going to tell you, it's not always going to work for you because I don't think you understand what graphing rational functions you've forgotten it, I would encourage you to plus minus test it because you're going to make mistakes. Okay, and the asymptote is the big issue with the errors. That's where your errors will be generated as a result of. And I will also tell you that some of them will cross horizontal asymptotes, which we're not addressing here. The horizontal asymptote causes all kinds of problems for us, especially if the horizontal asymptote occurs at the x-axis. So I would just tell you, stay away as best you can for right now. There's ways to do it graphically, but like I said, it's almost not worth it. I threw this one up just so you could see it, or I left it up from last period, because this polynomial, unfortunately, is not factorable. And when it's not factorable, you have to P and Q it. Okay? Again, seriously, we're talking about time, not difficulty. So stop your whining. Okay? Jeez. So in this one, there's only 8P over Q's that you have to worry about. Listen to you whine like a stuck pig. 3 over 2 is one of the rationals that does work. In fact, it's the only rational that works, so you may have had to go all the way through, because I know you would try the plus or minus 1 and plus or minus 3 first. But 3 over 2 ends up being your 0, leaving you with 2x squared plus 4x minus 2, which unfortunately you have to quadratic formula to get the other roots. Again, it's just time, it's not difficult. So I divided out the 2, and then went quadratic formula and got negative 1 plus or minus root 2. So for me, when I went up to graph, again, I don't really care what the value of negative 1 plus or minus root 2 is, just where is it? Negative 1 minus root 2 is over here, to the left of 0. 3 over 2, that's easy. And then you just need to make sure that negative 1 plus root 2 is either between or to the right of the 3 over 2. This is about 1.4 minus 1 is going to be about 0.4. So we know it's between the 0 and 3 over 2. We know that its leading coefficient is positive, the degree is 3, so the end behavior is down on the left, up on the right, and we have single roots, so we have our nice pretty graph.
If it's imaginary,
If it's imaginary, it's irrelevant to us because they're not on the x-axis. We only care about the actual x-intercepts.
okay.
That means that you're going to have a little wiggle above or below the x-axis, which doesn't change positive or negative for us. So let's just say that these two roots didn't exist. Then your graph would be down on the left, up on the right, so you would come through here. You'd go through, and there may be a wiggle. We don't care. We just know that this side would be the solution, or sorry, this is positive. Just this side would be your solution, okay, if you only had one rational root. Okay. But in this case, we have between here and here, non-inclusive, and then to the right of this one, also non-inclusive. Go on. Oh, split ends? Good to talk to Sam. Okay, so solving these polynomials, I'm going to graph. You can do whatever you want. In solving these, I'm going to plus minus test. Okay, every single time. And if you look in your assignment, all of the rational ones are either easy to factor or already factored, which makes your life a whole lot easier.